Hey friends, super excited to be joining the Devops Columbia meetup here. Kind of get a vibe for how everyone knows each other. Seems like you have a cool community. So today I want to be talking about securing debug access in GitOps environments using some cool tools that we can install. It's going to be Piniped as the focus of the talk. It's the core of what gives us some of these cool capabilities in our multi-cluster GitOps platforms. And this is going to allow us to solve some problems around identity, authentication, and bridging to the authorization layer inside of Kubernetes. Now, we're going to use another tool that does an almost similar thing called DEX alongside Piniped in today's demos. And that's going to give us our tie to GitHub because we're not just nerds, but we're hipsters, right? And we like our identity to be tied to where we like to do our work. So before I get into just talking about any particular technology or doing a demo, I want to break down a little bit and just get with you on the sorts of problems that we run into when we're collaborating with each other. Because at the core of it, why do we use computers, right? Why do we need an operating system, right? When we have our laptop and we're running Windows or Linux or Mac OS, we have that machine. The first thing we do is we pop it open, we log into it. Why do we log into it? It's because we don't want people who are not us to have access to the things that they shouldn't. Not that we don't like sharing, not that we don't want to trust people, but you can't trust everybody and you want some identity, right? So even when it's just one person on one computer, you're logging into that computer, right? And that's your user is denoting how much access you have. Now, then you want to share your laptop with your friend, right? Do you make them a user account? Are they using a guest account? Maybe the guest account can only do some stuff, but that's okay because your friend only comes over every once in a while and needs to use your computer once a month. So no big deal, right? Just a little bit of user management and access. Now, when we start using lots of computers and we start wanting to collaborate on software that's deployed to lots of computers with lots of people, say other engineers in your company, you got your manager who's wanting to know if you did that software release. Maybe the testing people, want to run some load tests on your software because it's Saturday and, there's not that many users during the week for your particular application or business. It's starting to get a little bit more complicated. It doesn't matter what technologies you're using, doesn't matter what business problems you're trying to solve. At the end of the day, when you're talking about organizations or doing business, in the modern day, we're going to be using computers. We're going to be deploying applications. There's lots of different personas and roles, and we have different incentives. But when the problem-solving constraints hit the road, you need to know who you're working with, and the people that you're working with and collaborating on the business problem, we got to have the access that we need, right? And so then you're talking about using Kubernetes. Kubernetes is just a computer. It's a distributed computer that lets you run apps and declare workloads and try to figure out what's happening with the state of what is potentially underneath many different physical computers, right? And Kubernetes has some cool APIs to make sure that you can help kind of decide what people should have access to. There's a whole authorization layer called role-based access control. Inside the RBAC APIs, you've got the ability to create roles and cluster roles. The roles are usually bound to particular namespaces, whereas you have roles living in namespaces and cluster roles that are available for binding across the cluster, whether it's to one namespace or no namespaces at all. And then you have role bindings and cluster role bindings, right? And role bindings can point to a role or a cluster role, and cluster role bindings can point to only cluster roles. And this is how you can start to say, okay, well, if I want to bind to some identity, I've got service accounts, users, and groups. And then there's also UIDs, which is a weird one. But those are the three types of principal, the three types of identity that are available inside of the Kubernetes API for you to start building your authorization layer against. And the reason that we have this problem again is because we're just trying to work with each other, right? Similarly, why are you going to do GitOps? well, the whole point is like, well, you've got this single computer and you're trying to collaborate with each other. But GitOps allows us to bring the declarative declarations that we are working on that describe how our distributed computer solves our business problems. And it allows us to keep them in a place where we can store them for longevity. Even if our computer goes down and we decide to replace it, we have our configs, right? And then we have a Git platform, right? Whether it's like GitHub Enterprise or GitLab, or if you're using Git or just something from the open source community, if you're just using a hosted service like github.com, right? We've got this platform that understands who we are, and it lets us talk to, it lets us comment, it lets us pull requests, it lets us propose changes to not just the pieces of the declarations that we're storing, but that we're versioning them, right? And so this is an inherently collaborative problem, right? We're using these tools to work with each other. And when we do the GitOps thing, right, and we put our Kubernetes config in some control repo, and we're like storing different environments in folders, right? And we're tagging on the environments so that we can pin different clusters to be rolling out. It's cool. We're happy. We're collaborating with each other, right? But at the end of the day, then something goes wrong in the cluster. And Git is not a debugging API for a distributed computer. It's just, that's not the problem it's meant to solve, right? And so normally you're collaborating with people and reviewing change in Git, and maybe you even have the control loop tuned so tightly, it's like you're not even using kubectl apply anymore. Like you do a Git commit to the repository, and like, boom, it's out there. It's deployed to your 3 clusters. That's awesome, right? Good place to be. But something goes wrong. Now you're going to have to go and dig, right? Like I'm logging into Kubernetes now, right? Just like how I pop open my laptop, I want like Kubernetes to know exactly who I am when I type in my password or like authenticate with somebody. So the question, and a little bit of what the demo shows today is like, what if Kubernetes knew who I was in the same way that my Git platform did? And what sorts of things would that allow me to build with my team? And what kind of least privilege does that allow me to realistically create instead of just like pretending like we do least privilege, right? Can we get closer? Can we reduce the number of identities that we're using and tie it all together so that we have a good time collaborating with each other, and we know that people have the access that they need to do their job? So talk a little bit about Piniped. Let's share our screen, right? Looks good. There's my editor and stuff. So yes. Pinniped.dev. This is the website, project website where you can start. And it says, hey man, this is a batteries included Kubernetes authentication system. And that is like almost the truth. And I will work as hard as I can to make it the truth at some point. Anyway, now, what does this do for me, right? I can go and I can install Piniped, and there are 2 components. There's the supervisor and the concierge, right? And I just go and I put that onto my cluster. And now I've got a place that sets up an OIDC identity provider to be integrated with my Kubernetes API. Now, there's something that's really special about Piniped, right? These are wonderful people. I was talking with some of them just today. Now, there's something about Piniped is that it can hook up to any OIDC provider, right? Like Google, super cool, right? Amazon, they got OIDC endpoints, right? It's a superset of how to do OAuth 2, and it's super standard. So like Piniped just has one implementation. You go hook it up. Same thing, you can hook it up to Active Directory. There's an LDAP connector inside of Piniped. But it doesn't know how to talk to esoteric stuff, right? Like just random OAuth 2 implementations, like for instance, the one from this company, github.com. It's like when you go and you log into your account here, this is not authenticating with the OIDC, unfortunately, right? And they don't have an endpoint or a way to expose against that, except if you're using like GitHub Actions, then like for some reason there's an OIDC connection connector there, you know, but there's no publicly exposed way for me to just like OIDC auth with GitHub. But there's another open source project that does know how to do that, and it's called Dex, right? If you go to dexidp.io, they have a plugin that's built right into the software where you can tell it how to auth with GitHub, and it knows like what to do and how to actually convert this to an OIDC endpoint inside your cluster, right? And Dex is cool because you can actually even modify the way that you've deployed Kubernetes. You can modify your API server flags, right? If you control the control plane nodes, and you can hook it right into Dex and start logging into Kubernetes with GitHub using Dex alone. Now, why am I using Piniped then? Well, Piniped has a really cool security model, and it allows me to use a couple of the components in the architecture to get away from having to modify my control plane nodes at all. So Piniped is able to, through two mechanisms, whether it's an impersonation proxy as the fallback, or by directly integrating with the PKI that's installed in your cluster through tools like kubeadm, using certificate signing requests, which is it's a core API resource inside of Kubernetes. It is able to issue short-lived certificates as well. So whether it's you're talking to the impersonation proxy or you're using these short-term certificates, Piniped's able to act as is able to delegate identities that give you access to a single Kubernetes cluster. And you install the Piniped concierge everywhere in your fleet, and you can start logging in. And you just will only need one installation of your supervisor on like a single management cluster or something. So I love to keep things interactive. And I know that I'm getting a little bit heavy with some of these acronyms and these ideas, right? And we're talking through, starting to do a complex deployment. We've talked about a little bit about the problem, but if you got questions, just feel free to like throw it in the chat. If you want to interrupt, totally cool. Let's like dig into it. Now, we want to deploy this supervisor to our management cluster, and then we're going to deploy the concierge everywhere. And what does that give me as a platform engineer? That means I don't have to know that if I am managing my Kubernetes cluster, like I'm going to go and integrate my API server's flags to like tie into my authentication system. It gets me away from having to solve that problem. And this is super important because a lot of times as platform engineers, when we decide to use Kubernetes and these distributed computers, we want to put a Kubernetes cluster here. We want to go and deploy one in Boston, in Seattle. We need a cluster in India because we got a user base there. We want to deploy in Europe because we're doing global services, right? And we got GitOps. We can go and take the same declarations and pretty much run them everywhere. And so who's going to give me all those Kubernetes clusters, right? Like my team doesn't have boots on the ground in Bangalore. Like I don't have a point of presence there. I don't have a point of presence in Seattle, but we got users there. Like we want to be there. And so we buy Kubernetes from somewhere else, right? Like we spin up an EKS cluster. We spin up a DKS cluster. We purchase a PKS cluster, a GKE cluster, right? An RKE2 cluster here. Some of these things we had to set up ourselves, but other times they're completely Kubernetes as a service. And I have zero access to actually change the control plane nodes. And so this is one of the primary problems that Piniped solves. The other problem that Piniped solves is that since we are using concierge in each cluster, the credentials that it hands out when you talk to that cluster are only good for that one cluster. There's sometimes when people are setting up OAuth or different sorts of authentication mechanisms across their fleet, the tokens that they're using actually bleed across the federation domain. But in this federation domain, or in this federation design, the tokens that you're using, right, whatever thing you have that gives access to a cluster does not bleed across environments. So that's an important part of the security model. Now, yeah, does anyone have any questions? You know, like kind of gotten into some social problem solving stuff, how this is like a socio-technical solution. This is about how we work with each other, right? Somebody's in the waiting room. I'm gonna admit them. Cool, sweet. All right, well, enough talking then. Let's do a little bit of a demo, right? Because this is cool stuff. I wanna show the value. So we're not just like in just Kubernetes land, because the truth about Kubernetes is that it is good at computing problems and it's good at authorization problems. but there's nothing that's built into the project except for like certificate auth or password auth, right? But Kubernetes is not an authentication system, right? You got to tie in, like put some authentication system on top of it. That's what we're doing here, right? So what you're going to want to do is, I got my control repo in GitHub, right? This is where we like to work. I like to like making commits here and like organize my code in folders and like talk to people and share my changes. And it is hosted inside of an organization, right? My org, this is like where we all like to collab with each other. So my org, you know, I got it configured. I'm going in here, I'm adding people, you know, HR just hired a couple of folks and we got this ticket open. We're going to go invite some members. They're going to join with their GitHub account. Super cool, right? You can enforce that people like need 2FA here. And then you go and you add some people into some teams, right? So I can make like a new team even, say, hey, like these are the Cube viewers. Oh, I don't want to be that excited though. Doesn't need to be all caps. Right, so here are the Cube viewers, right? This is to like inspect apps when we release them. There's no parent team or stuff, but you can build some interesting topologies here, right? And then I'm gonna go and like add myself to that team. Or well, I guess I'm already in this team, right? And why does this say team 0? Oh, there we go. So now I got like 2 GitHub teams, right? I'm a member of both of them. I could go and add some other people to them. But like, this is like where people, they're already setting up relationships, right? Groups of people and how we're gonna relate to each other, right? Some of these team members, maybe you're gonna have a dev team and they're gonna only have access to certain repositories. Maybe you're gonna make a code owners file and like some of the people in these teams are gonna be owners of those repository folders, right? And so like HR and your company, like this is probably already true in your GitHub account or whatever Git platform you're using to organize your code, because your Git platform is a collaborative area. It's how we collaborate, it's how we work with each other. And so it's gonna already encode these identities and these relationships and starting to pull in some roles about what people should have access to. You're gonna have some granularity already out here. And the cool thing is you don't even have to do this by clicking around. I've been in places where we actually define teams and team membership and membership into the org with Terraform, right? So you can do this as well in an infrastructure as code, GitOps style way. So cool. We got our team set up. So the next thing I got to do is I got to go into the organizational settings, and I'm going to scroll down here to developer settings, Oauth apps. I'm going to create a new Oauth app here, right? So I got one called the Flux TCE Piniped demo here. I'm going to come in here and I'm going to mint a client secret. And I bought this domain in Route 53 by just clicking some buttons and typing some stuff. So now I am the proud owner of YAML.tv. So we're going to host Dex, the thing that knows how to talk to GitHub, thing that knows how to tie in our GitHub login into an OIDC endpoint. I'm going to host that on a subdomain on YAML.tv. And then I'm going to configure the callback URL for here. So this is all the stuff that I got to do in GitHub. I don't know what this checkbox does, and I've never clicked it before, but that sounds cool. So yeah. I guess if you're like really proud of yourself, you could probably update your company logo here. So, so cool. I got my client secret now. So what am I going to do with that? Well, I'm going to go and I'm going to copy it, right? It's going to show it to me in the user interface just one time. And I'm going to go to my control repo. So here's my control repo. This is actually a public control repo out on the internet. Even though there's secrets in here and stuff, I'm encrypting them with a tool called SOPs. So for the most part, like unless you're live streaming and posting something to YouTube like we are today, if I'm showing secrets and stuff inside my repo, they're going to be encrypted, right? But I will show some secrets in this demo, and then I'm just going to decommission them after this talk. So I'm going to need to go to my config, and then inside of the config for the management cluster that I was talking about, where I got to deploy Dex and the Piniped supervisor, the things that are going to let me log in, the central hub for my federated platform, I need to configure some values for Dex and Piniped. And to do this abstraction creation, where I can just like put a bunch of values in a file and then build my Kubernetes configs into much bigger files, I'm using a Carvel tool called YTT. I really like YTT for just general YAML problem solving. If you haven't used YTT, come check it out. And once we get a little bit more through this demo, I can also show you some cool YTT hacks. But this is kind of similar in problem solving area to like the Helm template part of Helm, right? Where you can like write a bunch of templates and then it fills it in. Cool thing about YTT is it's YAML native and it's structured instead of like string templating. So, but yeah, I got this file. You can see some of these keys are just in plain text, and then some of these keys are holding like IDs. That's not so big of a deal, but this one is a client secret and it's an encrypted data, right? So I used SOPs for that, and I have a makefile that does that. There is this SOPs YAML that's using this age key right here. This is a private key generated by a tool called age. Yeah, I won't click it. Yeah. But what I can do is I will show you what an age key looks like. This is what a age private key looks like, and that's how you generate one. You just run age keygen. So this is just copied into a file and just wrote it out. And then you can also see that in the comment here is the public key, or I think you can do age keygen L of like a particular file, if I'm not mistaken. Or, oh no, it is Y. And that will show you the recipient's file, which that's that public key. So that's the programmatic way to do it. Make that a little bit bigger, get rid of this. Cool. All right, so you can see here in this sops.yaml, I'm configuring this to encrypt my secret. So I would just go and if I did go into the config management directory, well, let's do that one more time. So you can see I have this envrc that's loading in my age key file right here. And then I can just sops we're configuring dex, right? So do that, opens up my editor. So now temporarily I have the decrypted version of this, right? And then there you can see that I configured the client secret. There's other options in here, right? So I've like configured my host names and stuff. If you want to go and clone this control repo and then start applying it to your own AWS cluster, you come in here and, you know, like configure your domain and stuff. There are a couple of assumptions that this file is making. And one is that it's using my secure ingress stack here. So this has a bunch of package installations in here for like external DNS, Contour, and cert manager. And then there's, you know, like some configuration for the secure ingress. So here is a delegated certificate, you know, that sits in the secure ingress namespace, and then my Contour stuff can use that. This is the Acme issuer for that setup. So like, you know, this repo looks complicated, but really it's this Carvel folder that's holding the libraries for Dex, the concierge, and the supervisor for the Piniped project, as well as my overlays and configs to get that YAML abstraction. That is the important part, right? And so then looking at the rest of this stuff it's actually setting up my cluster for it to be able to be used. You know, there's like a webhook in here, but the management directory here and the workload directory are the parts that are actually configuring our authentication system to build our platform for how we're going to collab with each other, right? So what did I do? I went and I made an Oauth app inside of my organization. You can also do it on a personal user, and that will give them access to more organizations. Now I got my Oauth app, I made my client secret. I'm going into my infrastructure configs, and then before I get too lost here, then I go and I use the SOPs encrypted editor to go and configure my client secret. I save my file, and then I think I exit out of that. And then it says file has not changed, just exiting. So cool. I got my encrypted secrets and stuff. Awesome. Now I have this make file here. So this make file allows me to build the configs for my infrastructure, to actually deploy the infrastructure, and then also build the manifests to deploy the authentication configuration, right? And we can see that there's build targets in here for management, and then there's also one for workload, right? So I just run make and then these targets. And what happens is they output folders to the repository, right? So here, we're just like sourcing our private key. And then we're running this YTT build to source in all of the files from the project that are necessary for the supervisor and the concierge and the customizations that are needed. And then after it outputs the files to this folder, then I just run this find command on that folder to SOPS encrypt all the files, right? So it's like I've got a values file with secrets. Now I want to publish the manifests to build from those values files. But since the values are secret, of course, the output is also going to be secret. So I've got to encrypt them based off of the SOPS YAML rules. Sweet. Again, if you got questions about the setup, trying to show you some cool stuff here just to show you how I stay organized, because this is an effective way of not just keeping a repo in good health for yourself and using the GitOps method on a Kubernetes cluster, but then also scaling to working with your team. Instead of just committing like how I do, you can make pull requests on all of these styles of files changes. So basically I run that make. And then if you look inside of, say, the config management folder, there is an auth config and an auth infra folder here. That's the output of the YTT build. So like there's like the pinniped, concierge, and supervisor YAMLs. These are basically just like from upstream, but they're pulled in with a tool called vendor. And like I didn't write any of this stuff, you know, it's just pulled from the internet. There's just this like vendor YAML that shows where to get those YAML files from. So like these are HTTP URLs, and then here's like a Git repo that pulls the Dex YAML from the master ref of Dex. And then when I run vendor sync, it goes and it locks those things if it can. So like you can't really lock stuff from the internet necessarily, but you can lock which commit you're pulling in from. So that's pretty cool. How I manage the project.
Hey, Leigh, sorry for the interruption. Could you give a quick high level, like what is vendor and like what's a typical use case for something like that?
Yeah, so what I'm doing here with vendor is I can just basically, gonna go into the Carvel subdirectory. Yikes, using a new keyboard. So here's that Carvel subdirectory. Make it a little bit bigger. And there's that vendor YAML. And if I look at the vendor YAML, then what we can see here is this is a config. It's not a Kubernetes config. It's just a Kubernetes style config. And it's telling me that in this YTT lib folder, I want to create 3 directories. One directory is called Dex, the other directory is called Pinniped Supervisor, and this last one is called Pinniped Concierge. So if we were to look inside of this project folder, since I've already run vendor, there is a folder called YTT lib and 3 folders inside called Dex, Pinniped Concierge, and Pinniped Supervisor. It matches up to this vendor YAML, right? Now, those directory contents are going to be created from some different sources. So vendor is basically an infrastructure engineer's problem or solution to the problem of like, I need to take some source from somewhere using some protocol and then put it into my Git repository, pin that source so that it doesn't change on me because I'm checking it into Git, and then have a way to do it again when that upstream source changes. So some people might reach for like Git submodule or Git subtree, or they might reach for like npm install, you know, and like store the packages, like the node modules directory, like into their repository. And this is doing that same thing, except in a very general way. And why that's useful for wrangling YAML inside of a repository is because we get YAML from everywhere, and we need a lot of different protocols to do that kind of stuff. So in this case, I'm using the HTTP and Git protocols. I forgot the whole list of things that are supported, but I think you can even do like Mercurial and like, you can do OCI registries. Like you can get YAML from inside of a container image and like output it to a directory. You can do tag filters and all sorts of stuff. So like in this, this is the lock file, but in this case, like I'm just getting the stuff off the master branch. You know, you could apply like any git-ish ref here. You can filter for particular files. So like the Dex repository is actually huge, but I'm only interested in a single file from this repo, right? Like this is an entire Golang project that has like linters and like a maintainers file and all of this other stuff. You know, there's like Go mod being used in here. There's Nix configurations. I didn't even know that. Right. And then there's a bunch of Go source code and all this kind of stuff, but I don't need all of this, right? I just need a single YAML file from the examples Kubernetes Dex YAML file path. So I'm just only going to include just that one, right? And then when I run this command, right, so I got my vendor YAML, I'm in the right directory, and I just run vendor sync. It goes and makes a temporary directory. It clones the Dex repo. It checks the tags. It filters. It follows all my rules. Right? It gets the paths that I want. It puts them into the thing. It updates the lock file if it's supposed to, and then or follows the rules of the lock file if it was already there. And then it goes and it fetches the Piniped supervisor YAML from this place randomly on the internet and puts it into a directory, and it puts this YAML file into a different directory and outputs what it did, right? So super dope, right? I can even like completely remove the YTT lib directory with confidence, right? There's nothing there. And then I can just run vendor sync again. And I get all that stuff back from those upstream sources, as long as there isn't an internet outage or something happens to those things, right? But now it's checked into my repo. And so I have vendored the directories. So vendor. Does that make sense, Drew?
Yes, that is really cool. Thank you, man.
So this is half of the problem that I'm solving, right? Which is I want to use these wonderful pieces of software. And so I've gone to their upstream projects and I've vendored their Kubernetes manifests, right? They're just the general deployment examples. But that will only get me so far, because maybe I need to update the Dex configuration, right, with my own values, such as putting in and configuring the GitHub plugin that's part of Dex with my OAuth 2 client secret and ID, right? So I updated my values file, and now I have this overlays directory that has my YTT programs, right? So if I make this just a touch bigger so everyone can see, I have a schema where it shows like what sorts of values I'm supposed to put in here. And then I have like something to bolt on, like a Kubernetes secret. I have a way to patch the Dex configuration to remove some volume mounts that I didn't agree with, right? To change like where the config is coming from. It used to be a config map, but here I want to use a secret name instead, right? I can add my own ingress in here and then like pull in some annotations if I provide some different options, you know, stuff like that. Here's like the client secrets for GitHub. So I'm going to bolt on a bunch of configuration. I can use my YTT programs for that. Same thing for the concierge. You know, I need to make some additional custom resources to tell a concierge which OIDC issuer my identity should come from when I get credentials for the Kubernetes cluster. And for the supervisor, you know, a couple of other configuration bits. Like here's the ingress that exposes that thing on the domain that I need based off of the value I provide. So that's my little YTT project right there. It's like a medium complexity level thing. And the role that vendor is playing here is to help me get the stuff from upstream so that I can customize it with my own programs. Yeah. Then I use my make file and I use SOPs and I have my values. And now I have a way to publish manifests containing encrypted secrets publicly to my Git repository, so that I don't have to worry about my secrets being compromised without having access to the private keys. So while we're on the topic of private keys, there's something really cool. I would really recommend using age already. And those age keys are super easy to just generate. You know, anytime you need something to be a encryption recipient. So like in this case, I generated a private key for my cluster. I just do age key gen, and then I have like a thing in my make file to go install that key inside the cluster, right? Install management cluster key. It just takes that age key and puts it into a secret. So there's actually cool things that you can do. Like if everybody had an age private key, then you can configure here in SOPs to do multiple recipients, right? Like I can make this a recipient list. And that way everybody could encrypt and decrypt as long as they had access inside the repo to be listed, right? But there's something even cooler that's happening upstream that I can't wait for this to get some support and to merge, which is age actually supports using an SSH private key for encryption as well. And that would mean that you could use GitHub or your Git platform as a key server, and you could update your SOPs recipients based off of people's private or public keys. And so you would never have to touch the private key generation, since most developers handle, creation of their private keys. So some pretty cool stuff there. That's just a little comment on like encryption and identity and sharing identities in the Git platform side of things. Right, so now let's bridge the gap. I'm going to take you over to the Kubernetes cluster, where I'm using Flux to declaratively put this entire repository's configuration into action, right? So I have a Tanzu Community Edition cluster that I made with Tanzu Management Cluster create -- UI, right? Like I'm only going to make a management cluster once. So I use this UI, and then I like click this link and it pops open in my browser, and I'm like, yo, I'm like using AWS, and I go and deploy a cluster, and like, put your credentials in here, and you fill out all these details, and you click the button, and you can either just get your config file, or you can like repeatedly do this with the command line or with a GitOps method or whatever, or it just, you click it and you say, hey, please make a cluster. All right, so I have a nice beefy cluster. Don't need that anymore. I'm gonna hook up to it, just make sure my kube context is set. There I am on my AWS management cluster. I got a couple of nodes, right? And you can see here that I have done a Flux bootstrap GitHub, right? So I don't need to do this right now and like have all of the infrastructure roll out, because I've already run Flux bootstrap GitHub with the proper options and with my token and my environment variable that I got from Bitwarden and stuff. I keep my GitHub tokens in my personal password manager. Right? So now my cluster is set up, and I just do like a Flux get customizations. And you can see all of those bits. Like I have a bunch of folders, in the cluster that are related to here. And this is the top level one, Flux system, that applies all of the rest of these things to the cluster. Then they reconcile and they're hooked up to my commit, right? So I got my secure ingress stack. I have my package repos for Tanzu Community Edition. I have an installation of Kayam that came from a Helm release, using a bunch of different package managers here. And then I got my code from my Carvel project, right? That's got my supervisor. It has Dex. It has the concierge. It's got all of my configuration, my overlays wrapped up in there, come in from my Git repo. So it's cool, right? I did my YTT build. That's awesome. What does that get me? What it gets me is the one caveat is everybody that you want to have access your Kubernetes cluster, your multi-Kubernetes cluster federated platform here. If you want them to be able to log into Kubernetes so that you can work with each other, you're going to need this pinniped command line tool on your developer laptops, your manager laptops, whoever you want to be able to see stuff inside Kubernetes. And then that's cool, right? We're going to give everybody some level of Kubernetes access. right? So if they want to just like see if the app was updated or something, they can go and do that. But then the people in the kube admin group, right, they might have like some really privileged access so that they can go in there and delete, custom resources and maintain the cluster for us and stuff. So if you do piniped who am I, you get told based off of your existing kube config exactly who you are, right? So here it's saying, yo, this is your cluster. This is the URL that I'm using to access your cluster's API server, which in this case is just talking directly to the Kubernetes cluster. And then here's your username. Here's who Kubernetes thinks you are. And here are your groups. So you can see that everyone actually gets this system authenticated group as long as Kubernetes thinks it knows that you're somebody. And then there's also this system masters group. And there's a cluster role binding to this group that actually gives the cluster admin cluster role. So that's how Kubernetes admin from my MTLS authentication that just comes straight from KubeADM, which is what's used underneath the covers in Tanzu Community Edition, is granting access, right? I have a TLS certificate that says that I am this user and group. Kubernetes understands that user and group then are cluster role bound inside the RBAC authorization layer to give me access to a cluster role. Now, I don't just want to be Kubernetes admin forever, right? I almost want to delete this kube config because like, I don't want to access the cluster as an administrator. I want the platform to know who I am, right? So I can do a piniped get kube config. Let me just go up a directory here so I'm putting it in the right place. Piniped, oops, get kube config. I'm going to write that out to a file called temp kube config YAML. And so here you can see, oh, I have discovered this credential issuer, right? And this is the concierge operating in token credential request API mode, right? So this is the way that it's giving me tokens. And then, so this is like a native way of talking to the Kubernetes API without having to rely on a impersonation proxy. And either way, though, I don't have to modify the API server at all, right? I just install Piniped on the cluster and I don't have to mess with the control plane nodes. And then there's a couple of objects here like the JWT authenticator and the OIDC issuer, right? So it's like finding all of these endpoints that look to be similar to what I was configuring. And then I have this valid connection to the cluster. If I do a k-get JWT authenticator, as well as the federation domain and the OIDC provider, we can see that there are a couple of resources in here that I configured using Flux that have all of that information about what these issuer URLs and stuff, right? There's an issuer for DEX and there's an issuer for the Piniped supervisor. And everything is looking like ready and successful and ready to be used. So that's good. Now I can use that kube config, right? We just made a kube config YAML. A little note about this one is that it doesn't contain any secrets, right? So I said I was going to be showing some secrets on this call. So far, the only thing I've showed that was secret was a client secret for Oauth 2 for my connection to GitHub. But all the stuff that's in here, right? The CA, that's like public data. All of these these names and usernames and context and stuff inside this kube config, it's all good. What you see right here is that in this user section of the kube config, we're executing a auth provider. That's actually executing Piniped login OIDC with all these flags using the concierge, right? Passing the CA bundle. Here's the issuer. So there's nothing crazy in this kube config. There's nothing that we cannot, that we have to secure, right? I can just like go and mint one of these kube configs and then I can literally put it in my Git repository, right? Like that's totally fine. Like I could go and you can see I actually wrote this kube config out. Like I could commit that. That would be okay. There's nothing dangerous in there. And so my control repo can actually hold a kube config that tells people how to authenticate to the cluster. And that's a big deal right there. Like distributing kube configs this is like a huge problem. Just throw it in the Git repo. Not a big deal, right? There's nothing secret in there. So where are the secrets stored? Well, if I use the kube config and then I run, like say any Kubernetes command or talk to the Kubernetes API server at all, But in this case, I'm just going to say pinniped, who am I? Then it's going to authenticate with Kubernetes. Right here, I also got a warning because remember I made that team, right? Kube viewers inside of GitHub, right? So there's my GitHub organization. There's the team that I made earlier. It says, yo, this user has been added to the group. That's a GitHub team right there, right? It knows who I am. Here's the cluster I'm talking to. Here's my GitHub email address. Please don't spam me. And then here's like my username. Here's like my GitHub org that I'm a part of. Sorry, here's my GitHub org that I'm a part of. Here's the GitHub teams that I'm a part of. Here's another GitHub org that I'm a part of that I just authorized with the Oauth app to have access. And then there's also this system authenticated role that everyone gets, right? Pretty dope, pretty sick. The Kubernetes cluster knows who I am by just using this kube config that contains 0 secrets. So where did the secrets go? Well, if you go to the xdg config directory, which on a Linux and Mac system is .config in your home, then you just go to config, and then there is pinniped right here. And you can see that there is a bunch of credentials and sessions and stuff being stored here. So this folder is where the secrets are. Right? But there's nothing in the kube config that is unique to me at all. Like I can share that and just be like, hey, if you need to access the cluster, try using this and go and log in with GitHub. Now, if I remove this whole directory, just make sure I'm typing this correct. Cool. So I remove the directory. Now what happens when I try to ask pinniped who I am again? Right? I have no secrets on my machine. And so now it's being like, yo, you got to log in. And then this opens up my browser, right? I'm coming in here. I might as well just authorize since I authorized that before. Hit an SSO, VMware SSO. Boom, login succeeded, right? So what happens here is I'm talking to the concierge in my cluster. The concierge is like, hey, I got to talk to the issuer. What's the issuer? The issuer, in this case, is the OIDC identity provider, which is DEX, right? So concierge, supervisor, talk to DEX. DEX is like, oh, you're trying to log in. You want some identity. That's how I got to here, right? So going to pinniped, I got redirected internally to DEX, and then it tells me that, that it does the OIDC handoff. Between pinniped and DEX, I get redirected back to pinniped. Pinniped's like, I know who you are. Let me get you some Kubernetes credentials for this cluster. Sick. So that's one piece of the platform, right? Now the cluster knows who I am. And so I can go and start looking around, right? I could be like, hey, can I use that kube config, but then like get nodes? And the answer is no, because I'm not authorized to do that, right? This user is not allowed to do that, right? So this is where you start to role bind. Now, before we talk about role bindings and the UX of that, I got to talk about one more piece, right? So let's deploy a new Kubernetes cluster. I'm just going to create a cluster with kind. So we're using like real AWS infrastructure for the first part of the demo, but now I just want to show you how easy it is to tie any Kubernetes cluster into this federated auth platform, right? So lean in really close for this. Kind, create cluster. Just gonna make a cluster, right? So that would be about 50 seconds or so. What parts of the system do I need to deploy to this new cluster, right? I have to go into my config and build my workload configuration, right? And you can see I was messing with this earlier just so I knew exactly what I was doing, right? But we don't, that's for an old cluster. We can just delete that. Hello? Delete. Delete. Yes. Oh, okay. It was deleted. So I got my values again, right? I have my YTT project. I gotta build up some config. The things that I have to do, right? So I just have this pinniped host name and cluster audience. Oh, well, that's not so bad. It's not even secret, right? Like to configure all of my other clusters, I just have to find some way to point it to the pinniped supervisor issuer. And then I just give that cluster a unique ID. In this case, I just like literally generated some random numbers with bash and like made this very descriptive that it's a unique identifier. But if you want a good unique identifier for a cluster, then one way to do that is to get the UID of the Kubernetes service in the default namespace. It's the thing that like literally points at your API server, and it's a unique ID that Kubernetes generated. So that's one way to get a cluster ID. And then what does the config look like? Well, the infrastructure folder is literally just that file from the internet that we pulled from vendor. I didn't write this thing. It will deploy a bunch of custom resource definitions and stuff to the cluster, and then start running the Piniped concierge. So, you know, not a big deal. And then we have, this is the configuration, right? So this thing was just literally created from a values file. You almost don't even need a values file because it's just like, just those two things and this custom resource. And if we apply this configuration and this infrastructure to the cluster, we should be able to use the Piniped supervisor in the management cluster to get everything to do federated login and give me unique credentials for that federated child cluster. So assuming that kind can catch up at some point, I feel like I have been talking for probably longer than 50 seconds. Is this how long it takes to make a cluster these days?
Looks like the internet's taking a break. Oh, that's because you have an audience. That's why it takes a little bit longer this time.
Yeah, I guess it took 2 minutes. You know what it probably is? My computer is at like higher utilization than normal because I have a HD webcam. That's going to be my theory. Yeah. It's the problem with doing anything locally, right? So I made my cluster. I'm going to use another Carvel tool here. Anytime you want to deploy something to the cluster, you might think kubectl will apply. Well, cap is a tool that I would highly recommend using, or at least considering looking at, and I'll show you why. This is just going to make the demo kind of a little bit smoother. I'm going to do a cap deploy. I'm going to give it an app name. The app name is going to be Piniped concierge. This is just so that I have a way to stay organized inside the cluster. So this is one thing that is giving me beyond kubectl. All of the resources that I'm going to apply are going to get stored under a cap application. And then I just give it some files. And I want this to deploy my config for the workload cluster. And that's going to be the authentication infrastructure that holds the concierge resources, right? So the first thing that cap does is it presents to me a table, right? Since I didn't pass the yes flag here, it's like, yo, let's just make sure you know exactly what you're doing. Here's all of the cluster scoped resources. Here's some resources that are coming in kube public, some stuff in kube system. And then here's the Piniped concierge namespace with a bunch of infrastructure, right? So you can see the kinds of things that are being put in here. It's just a really great visible way to see exactly what's happening to your cluster. And if if there's like stuff that's already there, it'll tell you that it's not being created. It'll say that it's being changed or something instead. So this is pretty sick. There's even ways to like annotate the resources to build like a DAG between this stuff. So cap is very powerful. Now let's see what happens when I think, okay, well, I'm installing this cluster add-on. Looks pretty reasonable to me. There's like a couple of custom resource definitions and some key cluster role bindings and stuff in here, but seems fine. Technically, this is actually software that we use in our like paid products as well with tons of Kubernetes Grid. So I know the IAM team here has done like a really great security review of all this. So I just say yes. And then cap actually tells me what it's doing, right? So it made a bunch of resources in the Kubernetes API, and then it's also by default going to wait for those resources to reconcile to good states. So we can see here that, like, for instance, there's containers being created because there's a deployment that runs the Piniped concierge, and it knows like, yo, I should probably wait for these conditions to become ready before I go back to the user, right? So we'll just like kind of wait for this to go. It seems like most of the steps have been done, and we're just waiting on the maybe this login for concierge.dev. And there we go. So we deployed all of the Piniped concierge. I can do a cap list. And I can see that we have this and it's modified cluster scope resources, as well as these three namespaces. The last config, last something successful is true. And that was 46 seconds ago. Great. So we've installed the Piniped concierge. the last thing we need to do is configure it, right? So I might, and I could be using a GitOps approach here and do a Flux bootstrap, but since it's just a quick demo, that's why I'm skipping it. So I'll say now we need to cap deploy our auth config, and let's deploy the auth config directory, right? So I make a new cap application, says, yo, you got a cluster scoped resource called my supervisor authenticator. It's a JWT authenticator, and we'll just go and make one of those. Sweet. There we go. I can do get JWT auth, get rid of these resources because those are supervisor resources only. You can see there it is. So again, I made a new Kubernetes cluster, right? So who am I? Well, I'm the Kubernetes admin talking to this kind cluster at localhost. But if I do a pinniped get kubeconfig and I output that to kind kubeconfig, same thing, goes, finds the JWT authenticator, talks to the concierge. It's like, yo, this is how you connect. I have that kind kubeconfig. None of this is secret. I could send this to anybody who wants to log into kind on my laptop, but wherever we're running the kind cluster, it could be on like a dev virtual machine somewhere that's shared. And then I will just say kubeconfig, kind kubeconfig, pinniped, who am I? And if we've done things right, there you go. I'm already logged in. So brand new Kubernetes cluster. Now it knows who I am. That's my GitHub identity with all my groups and stuff, right? That's how easy it is to set up the concierge. And it provides the basis for your entire cluster or your entire fleet of multiple Kubernetes clusters to allow you to install a federated authentication system and hook it up into a hipster source of identity. So that's sort of the big idea, honestly. I've gotten into a lot of stuff here, and I want to provide some space for anyone who's joining to choose their own adventure a little bit. So if you want to, ask some questions and stuff, everything is fair game from this point. And I'd be happy to show you about the control repo or create some role bindings and show you, how to use some of that group and user membership with those principles, or talk about encryption and committing secrets to Git, or using other solutions like maybe a secret store like Vault. So happy to delve into things, and that's sort of the demo, the big idea.
That was really cool, Leigh. Thanks. Well, I'll give the audience a second to kind of absorb. That was a lot of material.
Yeah, hopefully I was able to tell a little bit of a story and kind of help you pick up on at least some key problem solving points. But I know that this control repo does look super intimidating and there's a lot of information. So if someone who was here tonight or is watching the recording, like if they wanted to do this on their own cluster, is there a place they can go to like kind of follow along? Yeah, basically, this is a great first question to look into. So if you go to the GitHub organization where I've been like messing with the GitHub teams and making the Oauth app and stuff, the control repo that is in this repository is public. And it has those encrypted secrets. Since I already recorded the GitHub client secret for my Oauth app, I'll have to decommission that. And then everything will be kosher again. But yeah, I mean, you can clone this repo. It's very finely tuned for you to go from a plain TCE cluster to exactly where I am if you're using Tanzu Community Edition on AWS. Right? So I have a Tanzu Community Edition management cluster. I have that managed cluster using its cluster API privileges to create some workload clusters and all of that. And yeah, so, go to Tanzu Community Edition IO, follow the README or whatever, or start, adapting this for deployment on your own cluster. And then all you have to do is there is a Terraform directory in here to create the AWS IAM roles, not users, it's just roles. And they prepare roles for cert manager, external DNS to update the DNS zones. I went into AWS and bought a DNS that automatically hooks it up to a zone in Route 53. And then I don't have to do anything else. External DNS knows how to use the AWS APIs to find it. So that works. And then once you Terraform, apply those things, then yeah, you just can Flux bootstrap the clusters directory. So like Flux bootstrap clusters management, and then that will start the whole chain of events, right? Like in this, when you bootstrap this directory, all of this stuff will start to get deployed, right? So here's the secure ingress stack. Here's the package repo.
Oh, we're not sharing your screen anymore.
Oh,
sorry.
Right. I forgot about that.
Oh yeah, please send the URL that you're talking about, because I can't find it myself.
Yeah, here we go. So it's if you can see on my screen now.
Put it in the chat, please.
Yep.
Thank you. I got lost there while you were talking.
Yeah, sorry. I totally forgot that I had stopped sharing my screen so we could like talk face to face. But yeah, basically go to Tanzu Community Edition IO if you don't already have like an AWS cluster. And then, there's like the install instructions for how to get started. Then Tanzu management cluster create UI. And then here's the control repo. You can either adapt to your own AWS cluster. You can just use this. And then in the root of this control repo, there's the TF KIAM folder. This sets up the IAM roles in Terraform. So even if you have a low privileged AWS account that like can't, modify things that like specifically, I was able to create this cluster and this KIAM setup with a role that was less than power user, right? So there's a pre-installed role, I think, that shows up in most AWS accounts, and I was able to use power user to create my DNS zone and then set up this Terraform. And then once you have your cluster and your Terraform set up for the control plane nodes to be able to authorize KIAM, then the rest of the config is just in this repository. And if you update the YTT values, you just have to run the makefile. You probably want to generate your own age key and put it into the cluster. There's no age key in this repo, obviously. Or I shouldn't say obviously, but you're not going to check your private keys into your Git repo. So when you clone this, you'll need to generate your own. And then the clusters directory, you would just bootstrap this management folder. It has the Flux system stuff, which comes there from Flux. And then this apply folder has a ordered list of things that have dependencies between each other, right? Or I shouldn't say it's a list, but there's a DAG, a directed acyclic graph here. So like the package repos is a root level thing, like that needs to be in there starting out, so there's no dependencies here. But certain things are dependent on the package repos, like the infrastructure. So the infrastructure for the secure ingress depends on this, right? And has like health checks. And yeah, just go and check out this repo. There's no README at the moment, and you'll have to probably rely on the recording to see how I went to the organization settings, right? So if you go to the org settings, then this is where the Oauth app is configured and that kind of stuff. But yeah, I do try to make demos that are as reproducible as possible. So go try it out. There's actually a local version of this demo that I'm not finished with as well, that is available on a branch. So if you want to try to do this on Kind instead, there is a repo called TDC Carvel examples. And then, oh, do I have this in a fork actually? I think I might have this in my personal fork. And then there is a branch here called pinniped.dev GitHub, and there is a folder here with very similar config. So I'll drop that in the chat as well. This is designed for use with a Kind cluster, and there is an incomplete guide here, as well as a bunch of notes and stuff. So go check that out. But yeah, those would be where to find the manifests that help you try and adapt these demos to your own experiments.
So how much time did it take you to arrive at this? This is really, to me, impressive. This is absolutely impressive what I saw.
Thanks so much. Yeah, I've been operating Kubernetes for a couple of years and in a developer advocate role for 3 years, I think. So I've been operating Kubernetes longer than I've been a developer advocate. And some of the solutions here just come from being so frustrated before in environments where there was no identity, where there was no way to, like, I was working with a personal customer of mine just last year who had Kubernetes clusters that were built by a outsourced firm that they had a disagreement with and were no longer doing business with. And that firm had deleted container registries, so they'd like lost some of the images that were hosting their things. So the Kubernetes cluster was just coasting along, like trying to keep the desired state. So like it would hit the kubelet would find images that were not available anymore on the internet, you know, and like keep running things. And the kube config that I was using was like minted for an SSH key of like somebody at the outsourced IT org, right? Like these are like very real problems that people still have. And so I was very motivated to build this set of examples. How long did it take me to build this example? I started putting some of the solutions to these problems together in late November or December. I already knew how to use Flux really well. So I really tied most of this demo together in like the past 3 weeks. But I'm really just working on helping like provide a good configuration for, I think, what is a very common, or what is a nice and attractive general solution to a very common problem, right? Which is, I think people would probably want to log into their thing with their GitHub account. So yeah, but thanks so much for the compliments. That's sort of the story about how this thing came to be.
So if you got a hold of somebody who was running, as you said, a no RBAC Kubernetes system, and they had to start this from scratch following this, do you think the video that you just gave, because it's recorded, you gave enough URLs in the chat, thank you, could it be replicated, really? Think about it.
I do think that it could be replicated. There are some bits that you could definitely even throw away if you were not ready for GitOps, right? So if you're not already a Flux user, right, then starting with Flux is maybe its own journey. And of course, like I'm going to be pushing a README that shows like the dependencies that you need to install and the steps that you can take to go and replicate this on a new cluster. But for sure, the fact that it's in AWS adds a little bit of a bar to entry. The fact that it's using GitOps has a little bit of a barrier to entry. There's Cert Manager and external DNS with the secure ingress stack. That, you know, is its own set of problems that are being solved, right? But now you're at the platform layer and like you have something valuable with the way to expose services. So with those problems solved, then that last bit of getting Piniped into the management cluster and all of your federated clusters, that's a pretty easy step to take. And I think a lot of platform teams are there. Right, a lot of platform teams, they've started installing add-ons and they're just trying their hardest to stay organized. It's probably the hardest problem on Kubernetes is like following the methodology to the conclusion that it gets you to like a single declarative or a declarative repository source for your configuration. And instead of just like operating imperatively and iterating on the cluster.
You think it would be a problem to switch over from Argo CD, or do I have to use Flux? actually
I
go
don't think that
forward.
it would be a huge problem to switch to Argo CD, and nothing would stop you from using cap or kubectl to just apply these folders to your cluster to experiment with the ideas.
Okay.
But the great thing about it is and cap controller would be another choice, right? Like I'm already using cap controller for the package installs of the secure ingress system. The package installs are dependent on having cap controller installed in the cluster, which is done by default in a Tanzu Community Edition cluster. So that's one reason to recommend using Tanzu Community Edition for this particular repo, but there's no reason why you need to use those package installs to install external DNS, cert manager, and Contour, right? It's just the way that I did it. You could install those add-ons any number of ways. And since those things tend to be configurations that are fairly separate from the way that you actually use the tools, then the rest of the manifest in the repo will work. The other benefit is that even though you don't use Flux, you can look at how the dependencies are laid out in the repository. And so that can inform, like if you want to configure your Argo CD apps, to have dependencies between folders instead, that kind of a thing. And I think you could be pretty successful there. Yeah. Or anybody that you show the recording to.
It's a real try. I really am. Thank you.
I'm really glad to hear that. I've given this talk to a very small number of platform engineers now, just on 2 other meetups. And I think that there is a sweet spot, like for people who they're past a little bit of the Kubernetes learning curve. They're starting to deploy real services.
Hey, Leigh, sorry for the interrupt. Your mic just went totally haywire. I don't know if you can try unmuting, muting. Not sure what's going on for you.
Does it sound bad still?
Yes.
How about this mic? Does this work?
Crystal clear. Thank you.
Perfect. This is my webcam's mic. I was super happy to find out that I could ask VMware IT to send over a Logitech Brio Ultra. It's 4K HDR, and I didn't have to wait a long time to get it either. So
it's nice having that.
Yeah. Definitely a little bit of a difference from working at a startup. Although if I needed a webcam, I'm sure Weaveworks would have just comped it for me. I can't believe I haven't been using one of these things for a long time. I mean, the picture quality is so much nicer. It seems like, I think there is what I was saying is there's a sweet spot for people who are just past the Kubernetes learning curve, deploying real services. Maybe these people even came from, or very likely these people used to manage infrastructure in other ways. I used to be a Puppet sysadmin, right? And used to be a vCenter vAdmin. So there's a lot of people out there who know the pain of like managing systems, and with Kubernetes not having a strong opinion about how you solve the authentication problem, I think there's a lot of people out there with the production services on clusters that they're just kind of safeguarding the admin kube config too, So I think this resonates with a lot of people. You don't have to modify the cluster infrastructure. You just deploy Piniped, make sure you configure it, get all the TLS set up so that you can host that thing either on your public internet or on the private intranet, VPN or whatever. Just have some endpoint that people can always hit and log into your Kubernetes cluster with GitHub and start role binding to people's emails, usernames, or groups, probably more ideally. So, yeah. Awesome. Well, that's pretty much the end of my content and stuff. And of course, I'm happy to talk about more questions and stuff. You know, I could add a little bit more value by showing the power of YTT. I have like probably a short thing I could show if anyone's interested.
Yeah, I mean, personally, I'd love to see it, but I mean, yes, please do.
So here in the control repo, if you go to the Carvel directory, I just want to talk a little bit about why I like YTT so much and contrast it a little bit with why I dislike Kustomize so much. So that's going to be like my sarcastic, jaded infrastructure engineer, sysadmin hot take on the world for today. And there is a lot of power in something like Kustomize to let you start wrangling YAML, merging over it and stuff. And it's got like a really simple interface, right? Like if you just want to patch something, you go and make a file and you start putting the fields in it. You don't have to put all the fields together. You just put them in the same Kustomize project and Kustomize will patch it. Awesome, right? You just set up the customization YAML. And that's like an approach that can work until it starts getting in your way with more complex projects, or as soon as you want to do something like what Helm is really good at. So Helm is great at this problem that I was talking about earlier, which is you got a bunch of templates and you want to make a data value abstraction of those templates so that the next time that you're making variants of the templates, you don't have to supply all the config, you just supply like a couple of fields. And if you want to put a host name in there and then have it expand into 7 different places in your config, Helm is great for that. So is YTT. Kustomize sucks at that problem because like you have to like make your overlay with all of the resources where you want to like put the thing in, and maybe if the thing needs to change, you don't have any like functions and you have to like repeat the thing like 7 times. It's just not a great tool for it. The other thing is that Helm is a Kubernetes tool. Kustomize is a Kubernetes tool. YTT is not a Kubernetes tool. It is a generic YAML slicing tool. It is a programming language that is just kind of natively parsed out of regular YAML comments. So let me show you a little bit, right? We were looking at some YTT programs earlier, but if I want to produce some TLS secrets, right? So here is a Kubernetes secret YAML that you copy from someplace on the internet, and then you can start interpolating with these YAML comments, data values, dex TLS secret name, right? And there's an editor integration here. The language that's being put in here is Starlark, which is Pythonic. And then the parser comes from YTT, and there's an editor integration for YTT highlighting. So I have that on any .ytt.yaml file in my configuration. And sweet, so look, I can make this conditional, right? I can say, hey, if this data value is provided and put this thing in, cannot do something like that with Kustomize, right? But this is like some pretty simple stuff. I'm like loading in a library up here and then pulling in some data values. And YTT natively has a way to define a data schema and to provide values via the command line, right? So super cool. If you look at the make file, right, this is how you provide a data values file. And you can see that there's the inline SOPs decryption there, right there. So I'm decrypting the YAML file there and then passing it through to build the config. That's obviously a privileged operation here, right? Because it requires access to a decryption key in the receivers section of the SOPs YAML. Cool. So that's a simple case, right? I want to produce a resource like a secret. This is just adding a document to the file or to the output of the YTT run. There's other cool things that I can do. So when I output my project, if you look over here in the build of the config, you can actually see when I expand this, that there are multiple YAML files with names that are human readable. Like I can look over here and see that there's an ingress, a JWT auth resource, an OIDC client secrets. So there's probably some secrets in there. And then a fed domain. So it's probably a federation domain resource. How does it do that, right? Because it's a YTT build. Shouldn't it just be like giving me a bunch of random YAML output in a single standard out stream? Like, why is this all separated nicely? It's because YTT tracks where resources came from in your project, and it uses this thing called file marks internally, so that if stuff came from some YAML file, that will also be output into that YAML file in the directory that you use for output. So I would recommend using that feature instead of just using standard out. And it makes things really nice. For instance, remember that we pulled that dex YAML from something called examples Kates in vendor? Well, it shows up in my YTT output as examples Kates, except this stuff is actually patched, right, by the stuff that I want. So it doesn't have like those TLS mounts anymore. I was able to overlay and like take them out. And then it has my updated config. And you can see this is also SOPs encrypted. So that's why there's like a lot of these extra fields in here. But I could SOPs decrypt it and look at stuff, and that doesn't stop me from like seeing the non-secret values. Cool. So I think that that's another important like usability thing there, because Helm template does a little bit of this, but not really, and Customize doesn't really do that at all. Now, lastly, this is a full programming language. Right, so I can structure my project however I want, and I can import things and use libraries and as powerful as I need to express my concerns. And it composes really well with things like vendor, right? So I've pulled in some like stuff as if it was a library from random places on the internet, have ways to update those things using vendor lock. Now, if I want to overlay something, say this patch dex thing, I can be very explicit about what I want to be overlaid, right? So I can match any object that is a subset of these object fields, right? And if I specifically put something that's very much just one object in Kubernetes, I can do that. But here I'm finding all deployments that are labeled app.dex, right? So I'm no longer just, I have to go and find something by namespace and name. Right, I can do group version kind labels. I could do group version kind annotations. I could just leave off labels and just match every single deployment inside of the entire project. So that's something that's really powerful and expressive. I think this is a lot more expressive than the matchers that are available in Customize. In Helm, you don't really find yourself doing overlays because that's just not the way of programming. But in YTT, this is a very primary way of configuration overrides, is to use the overlay library. And then instead of just matching whichever way the Kubernetes strategic merge patch thinks it should do it for my particular API, if you don't know this about Kubernetes, there's a thing called strategic merge patch. And the strategic merge patch follows on merge keys. So for containers, for instance, the merge key is name by default. Well, YTT isn't a Kubernetes tool. You can overlay match on anything, right? So here's a containers list. I choose to match by name. But instead, I could match by any container that has an environment variable set, or any container at all. Like I don't need to restrict it to just containers with the name. Or with a particular name, I can, match anything. I could add an init container or a pre-stop hook to all of the containers in a list very easily without having to worry about what the strategic merge patch thinks it should do. And then you can like replace and remove and do intricate things. So really powerful set of stuff from YTT there. And then probably the most complicated thing you can do before actually writing Starlark files, because you can just write functions in Starlark and use them inside of your YAML patches and stuff, is you can actually parse values. So, and here I'm finding an object called dex with the dex namespace that has a config map directory, or what am I saying? A kind config map. And then when I match on that object, I'm going to overlay this. So I'm actually going to change the kind to a secret. You won't find yourself doing this in a general Kubernetes tool, right? Like that is a very esoteric low-level thing that I'm doing here. I'm changing the entire schema of this object. Well, I didn't like that the dex config was telling me to put secret values in a config map, right? So let me just change it. And then I actually have some raw YAML here up top called updates, right? So like here's a little function that's being created that outputs a YAML struct. Now this YAML, it's a dex configuration. This is not a Kubernetes object, right? Dex actually accepts its config as YAML. And if you look in the upstream object for dex, you can see I've been here before, right? There's this like inline YAML string inside of the dex config. Well, I like any infrastructure engineer gluing stuff together, right? I probably copied this at one point, and then I looked in there and I'm like, how can I configure stuff, right? So you can see here, there's a GitHub configuration here, but it's configured for the Kubernetes organization. Like I don't have access to create Oauth apps in the Kubernetes org, but I can use YTT. If I go back to that YTT patch, I can write my own bits of dex config. So I'm not concerned about the other stuff, but I can change from using HTTPS to using HTTP. So I can delegate to my ingress for the TLS upgrade. I can disable options and that kind of stuff and store this YAML, right? I can pull in my values for my GitHub organization, whether I should like do loading groups and like pass different things in here. Tell it like which environment variables are being mounted by the secret. Here's the static client configuration that is used to hook up Piniped, right? Like that's my dex config, not a Kubernetes object. But I can use this overlay replace function and provide a Lambda that will YAML decode the left side of the merge, YAML decode A, and then overlay apply my dex configuration updates. What is this doing? This is grabbing this inline YAML string from my matched object, and then it's decoding it into a Starlark struct, applying my updates, re-encoding it in YAML, and then lastly, adding a base64 encode because I changed this thing from a config map to a secret. So I'm able to actually do some really creative programming and make this configuration more secure, and then also inherit the structured YAML base configuration of something that I pulled in via vendor, right? So this is overlaid on top of all of this other stuff, right? So like if there are any fields in here that I didn't configure, such as this like storage section, like this is not in my config, but it is in the final config that's overlaid. And you can do this stuff inside of Helm because it has a very powerful standard library available in the Go template context. The con being that you're Go templating, so it's like indentation specific and all of that. But you cannot do this kind of thing in a restrictive Kubernetes specific tool like Kustomize. But since YTT doesn't care what your config files are, whether they are Kubernetes YAMLs, Docker Compose YAMLs, GitHub Actions configurations, or some inline YAML string from some random project like Dex, you're allowed to do whatever you want using the power of Starlark embedded into YAML comments to slice things all together. And you can graduate from very simple definitions like this one, which are very easy to understand by anybody who knows YAML and a little bit of indirection logic, to patches that are more similar to this, which are still doing overlays and that kind of thing, but are mixing and gluing domains together. The Dex configuration domain and the Kubernetes configuration domain, and then still giving me the power to make this object more secure than it came by default. So yeah, that's why I'm really into YTT. It is a total power tool. if you're using YTT with vendor, I think that a lot of your YAML management problems inside of repositories will be a lot cleaner. It's going to empower you to fork YAML. Basically, like that's the, I mean, it doesn't have to be YAML. Vendor can pull in anything, but you know, YAML is one of the things that we are working with frequently. And then overlay over it and append to it and mutate and change it into the thing that you actually want without ever having to copy and paste something and lose the source provenance of where you got that thing. So yeah, that's my little YTT demo.
I love it. That was cool.
Satisfied some curiosity, Drew. And,
Thank you for that, man. Yeah, that's always like, I think that was an excellent way of putting it with the YTT thing, is that YTT isn't really a Kubernetes tool. It's made for slicing up YAML. So if there's anything that speaks or uses YAML, like it's, you can thrive with that.
Mm-hmm. I believe it also, like you can decode INI files and JSON and stuff as well inside your YTT program. So yeah. Don't think, I don't remember if you can control the output format as well, but yeah, pretty much just anything structured should be good to go. CSVs as well. So,
Well, cool, man. This has been great. We'll open it back up to the room for any last comments, thoughts, or questions. I'll give that a pause just in case. But
thanks so much for joining me, everyone.
Yeah, thank you, man.
I'm super stoked as well. You know, if we do any hanging out afterwards or something, but I do know it's that school night, as you mentioned. So yeah.
Yes. Last question, Leigh. Where can we find you on the internet if we want to keep up with you?
Yeah, I'm pretty active on Twitter. Is like my main like professional place where I like to interact. So that's Twitter at Capili, CAPILEIGH. I'm also available on Instagram, Leigh Capili, my name. If you want to see updates from my life, I like to put like some snowboarding videos there every now and then. Also pictures of Pepsi and Tanya. So
Cool.
It's my wife and my 60-pound dog. And yeah, I mean, GitHub, StealthyBox, Kubernetes Slack, CNCF Slack, and StealthyBox there. So yeah, hit me up. My DMs are open on Twitter. You can definitely reach me.
Cool. Awesome. Thanks again, man.